Hi, my name is Brandy Wales, and I am going to tell you how I teach computer science in 3rd and 4th grade. Each class begins with a daily message. The purpose of the daily message is to explain what we'll be covering in class and define any new terminology. Classes consist of a variety of unplugged and plugged-in activities. Unplugged activities are important because they teach my students that computer science is a way of thinking, not just about using a computer. One example of an unplugged activity is this movement game that I named If Else. Each child had the chance to be a programmer and learn about the commands if something happens, there's a reaction, else there's a different reaction. Let's watch.
If you have a younger brother, clap your hands 10 times. Else spin in a circle.
So the kids had a lot of fun. They were outdoors and they learned something new about computer science thinking. I also like to include unplugged hands-on activities like this activity my 3rd graders did to learn about functions or procedures. First, we defined the term. A function or procedure is something that calls upon a repeated set of commands. I gave an example about what that might look like in real life, and I used tying your shoe. When you first learn to tie your shoe, your brain has a lot of steps to memorize. First, grab your shoe. Next, put your shoe on. Then, grab one shoelace. Then, grab the other shoelace, and so on. We talked about how cumbersome it was in the beginning, but soon their brains recognized the procedure tie shoe, and it happened pretty instantaneously. Even though they're going through lots of steps in their mind, it's simplified. Put your shoe on, then tie it. In this activity, students were given a large program, and it was how to bead a sun catcher, or a bracelet, or a keychain. The point was they were going to bead something with a long procedure. First put a bead on, then tie a knot. Then put a bead on, then tie a knot. Then add a special bead, then tie a knot. They repeated that twice. We talked about how it would be easier to break that down into multiple procedures that you could repeat. The students ended up creating 2 procedures, Procedure 1 and Procedure 2. And the program ended up being Procedure 1, Procedure 1, Procedure 2, instead of the long program like you can see on the student work on the picture. This was an awesome activity. Kids had a lot of fun, and they got to take home a keepsake to share with their families. Sometimes I like to read a computational fairy tale to my students before beginning a lesson. There's a picture of the book I like in the top by Jeremy Kubiak, and these stories introduce the fundamental computer science concepts. In this example, 4th graders were learning about while loops, and they learned about them through this fairy tale about a blacksmith and his apprentice. So you can see it says, in this case, continued Drex, I want you to keep hammering that horseshoe until it's flat. As soon as it's flat, you can stop. While the horseshoe is not flat, hit it with a hammer. So it teaches computer science concepts in a super fun way. I think it is really important to teach the computer science fundamentals through play, especially for students who are elementary aged. In the next 2 examples, I'm going to show you about how students learned about different types of loops. In this first activity, 3rd graders are learning about a basic loop. And they started by physically repeating a loop in an activity we did in class with movement. So here I'll let you watch them.
Stop, left, clap, right, forward, backward, jump, jump, clap. Stop, left, clap, right, forward, backward, jump, jump, clap.
They had such an awesome time. Then we explored the website Made with Code, and there is an activity on there where students mix their own beats. So it was another way for them to apply what they learned about loops by creating music. In this example, fourth graders are learning about a more advanced loop, for loops, by playing a dice game. So this is just a little snippet of their game board. But you can see first we defined the definition of a for loop as something that has a beginning and an ending number as well as an incrementing number. So to practice, the students were in pairs and played this dice game where in this example you can see player 1 had value x 1 to 11 incrementing by 6. So from 1 to 11 they circled only two numbers, 1 and 7, and got a score of 8. Player 2 had values x 1 to 9, incrementing by 2, so having the smaller increment really helped because they had more numbers to circle, totaling 25. So in that example, player 2 won. Whenever possible, I like to include real-world application and share with the student examples of jobs and things that people are doing outside of computer science class that involve what we are studying. So in this example, a woman from Twitter talks about using variables in her everyday life as part of her job. So I'm just going to show you a very tiny clip of it so you can see it.
We use variables all the time in our work. So anytime you need to store a piece of information for later, we'll use a variable. Let's say we need to count the number of times that a user has tweeted. Every time that user tweets, we'll add 1 to that number, and every time that user deletes a tweet, we'll decrease that number by 1. Anytime we need to know how many times the user has tweeted, we'll just look at that variable.
In addition to unplugged activities, there are plenty of opportunities for students to be plugged in, trying application, software, robotics, and I'm going to show you a few of them. In the beginning of the year, students begin programming with Code Studio, which is created by code.org. Students will apply the foundational computer science skills as they program with Blockly, a block-based language. And you can see an example of the block-based language are those colorful snapping blocks that click together. I think it's so important to teach programming with block-based language for our beginning coders because it focuses on ideas and concepts and takes away the syntax. This is an awesome 1-minute video that kind of summarizes why it's important to use block-based language with our younger learners.
I'm Dan Garcia. I'm a senior lecturer SOE here at UC Berkeley. In the olden days, we used to teach using a text-based language, and there'd be a fair number in the first month of mistakes just based on typos. We've moved at UC Berkeley and at many universities across the country to a blocks-based language, which has graphical blocks that you drag and drop into the place. And what that eliminates is all the syntactic errors that you often get with text languages. We don't see the same errors. The students are able to jump past it and skip almost 2 weeks of, here's how you check for a missing parentheses, here's how you check for a missing semicolon, here's how you decode the arbitrary and obscure error message because of the missing semicolon. We don't have that anymore. It's just as powerful as a text-based language. It just is easier for first-time programmers. You want to have people have an exciting, engaging experience in computer science to be able to then think, maybe there's a future for me in this field, or even if not, if we do our job right, they'll have enough background, so if they never take any more computer science courses, they'll have enough of experience, enough of a background to be able to use the computing that they've learned, computational thinking, in whatever field they happen to choose, because it's going to be impossible to find a field that doesn't have computation affecting the field in the future.
It's really fun. You want to play?
I always encourage collaborative problem solving because it helps students learn together and from each other. I'm always giggling and joking with my class that if it gets too quiet, I'm a little bit worried because we're not solving problems together. So here's just a brief little example of two students helping each other on a Code Studio activity in the beginning of 4th grade.
Oh, too small. 500.
In this example, students are learning about sequencing by using robotics. They are using Wonder Workshop's Dash robot, and they are programming him to get the snow, which are little puffballs, off the red brick road, which is this red piece of paper that I've created that is a giant grid that has squares on it so the students can count and manipulate their program to move the snow to the snow collection center. So here is just an example of the students working on that, and then directly after an example of some other students working on a sequencing activity at their computer.
Sunfish book, great book. Sunfish, great book, great book.
In this Lego Robotics Challenge, third graders are trying to help Mr. Mahiri with a big problem he's having. Mr. Mahiri is our science teacher, and he is ready to plant a garden, but his supplies are awfully heavy. Can you help? He needs you to build him something that can pull his gardening supplies from the shed to the garden. He's crunched for time, though. He needs this built in the next 30 minutes. So their programming challenge is to program something that can pull his supplies. So they need to use their programming language and building skills in order to create this structure. And here's some example of students working on it.
So your idea is a pretty good idea, but we have to wipe our hand in front of it.
In fourth grade, students have been working on book trailers using the program Scratch. These two girls created a book trailer for the Sutherland nominee Do Is Talk. To start, the girls designed backdrops of the different scenes for the book using the paint. Next, they programmed the backdrops and the sprites for the characters. Enjoy!
Hello, my name is Naksha. And I'm Sophia. Today we will be presenting about Do Is Talk by Carson Ellis. This story is about insects who try to figure out what a plant is. They use their own language to talk through the book. This story takes place outside in a garden-like place. This story begins when two damselflies wonder what a plant is and try to build a fort on it. Next, a spider and a bird destroy the fort. The plant sprouted a flower bud, which soon turned into a grown flower. Finally, the flower dies, but new plants sprout out for them to wonder about. We like this book because you can interpret it in your own words, and it's different from all the other Sutherland nominees.
There are many other ways that I teach computer science, and it evolves with the changing of technologies and student excitement and engagement. So my curriculum is very fluid. However, one thing that is always constant in my class is an opportunity for authentic reflection. I use exit tweetbooks based off of Twitter. So I provide the students with a hashtag. For example, this is hashtag conditionals. And they need to answer 2 questions in their exit tweet. What is it? And how did you practice it in class? So let me read you an example of 2 students. This one says on the top, something I learned today is that hashtag conditionals are statements that only run under certain conditions. Today we played a game called If Else. In this game we worked with conditionals.